In this video, we're going to look at an example using Harris Health Systems to find a confidence interval. Our scenario: Harris Health Systems expects that at least 87% of their employees get the flu shot every year. Without having the time to efficiently ask all employees, Harris Health System decides to take a simple random sample of 300 employees and estimate the true proportion of employees that receive their flu shot. Of the 300 employees sampled, 249 said that they received their shot in the last year. We are to create a 95% confidence interval and determine whether it's reasonable to conclude that Harris Health Systems met their expected goal of 87% of employees. So in order to create a confidence interval, we need to look at the formulas and what's required. Our formula tells us that we need to find the proportion for the sample and then add and subtract the standard error. So in order to find the proportion for the sample, we take the number of employees who did get their flu shot, which was 249, and divide by the number in the sample, 300. And the decimal for that is 0.83. Our formula for E is that we take the value from the normal curve for alpha over 2. We multiply that by the square root of p hat times q hat divided by n. So before we go into calculating this number, we have some conditions that need to be met. So our conditions are that it's a simple random sample, and we saw that up here that they took a simple random sample, so that condition is met. The conditions for binomial, and so we have probability of success right here. We can take 1 minus that, so let's do that at the moment, q hat. So 1 minus 0.83, and that would give us 0.17. So we have the probability of failure, and we have 300 events, so we meet the conditions for the binomial. Lastly, in order to use the normal distribution for an approximation, we need to have at least 5 successes and 5 failures, and we definitely meet that condition as well. So next, we need to figure out the value of this z alpha over 2, and we're told in the problem to create a 95% confidence interval. So for 95% confidence, our corresponding alpha value is 5%, and our critical value 1.96. So coming back here, we have 1.96 times the square root of 0.83 times 0.17 divided by 300. I'm going to do that calculation on my calculator, and I get 0.0425. So in order to find the confidence interval, I'm going to take my point estimate of 0.83 and add this and subtract this. So 0.83, subtract first for the lower limit, 0.0425, and then I'll take 0.83 and add 0.0425. I'm going to round both of those numbers to 3 significant digits, and that gives me a confidence interval of 0.778 to 0.873. So I am 95% confident that the true proportion of employees who got their flu shots is between 0.778 and 0.873. Second part of the question asks, is it reasonable to conclude that Harris Health System met their expected goal of 87%? And when I look at 87% as a decimal, that would be 0.87. That is in my confidence interval, so yes, that is reasonable. Let's take a look at this problem with a 99% confidence interval. So we have here create a 99% confidence interval. So before we did 95, let's take a look at 99. So we know a lot of our values from before. So we know our p hat value is 0.83. We know our q hat value is 0.17. But 99% confidence is going to give us a new value for z. We know these conditions are met, so that's not an issue for us. So we'll look up our z-score, and we want 99% confidence, which means that we have an alpha value of 1%, and we're going to have to use a critical value of 2.575. So in calculating E, we're going to fill in for that z of alpha over 2, 2.575. And then we have the square root of p hat times q hat divided by our n, which is 300. And I put that on my calculator, and I came up with 0.0558. And to find my confidence interval, I take my point estimate, 0.83, and I subtract that. And I take my point estimate, and I add that value. And so that gives me a confidence interval of 0.774, and again I'm rounding 3 significant digits to 0.886. So I am 99% confident that the true population proportion for flu shots is between 0.774 and 0.886. Now let's compare our two confidence intervals. We were 95% confident that the true population proportion was between 0.788 and 0.873. And then we were 99% confident that the true population proportion is between 0.774 and 0.886. So I'm going to draw just a little number line here. And down here is 0. Up here is 1. So for the first confidence interval, we're from 0.788. So we'll put that here. 0.788 and 0.873. So here. We are 95% confident that this range includes the true population proportion. So this is where we were 95% confident that if we surveyed everybody, that true population proportion would fall in that range. Now I'm going to change my pen color, and we'll look at the 99% confidence. So our lower limit was 0.774, so it's down here. And our upper limit is 0.886, so right up here. So between these two, we are 99% confident that the true population proportion is in that range. So you see that with our confidence level going up, the width of our confidence interval also went up. So in order to be more confident, we have to give a bigger interval. But if I give a smaller interval, here in the black, then I am slightly less confident. And that's always our dilemma in statistics. We want to be able to balance. We want to be very confident, but we want to have a very small range. And so if we increase our confidence, we also have to increase our interval. And many people find that that balancing point is here at the 95% confidence, and that is why that is the most common confidence level used. If we went to 90% confidence, so our confidence went down, our interval would also shrink.